Morning friends, welcome to Padla Tutorials. Chapter 1, Matter in Our Surroundings. Exercise Solution Part 2, Class 9. Page 12. Question 1. Convert the following temperature to Celsius scale. Friends, we know that once we want to convert the Celsius to Kelvin or Kelvin to Celsius, degree Celsius, we have one number, that is 0 degrees Celsius is equal to 273.15 Kelvin, that we know, which is approximately about 273. So if you want to convert 293 Kelvin into Celsius, so what we can do? We will subtract 273 from 293, we will get the 20 degree. Similarly, 470 Kelvin will cut 273 and will get 197 degrees Celsius. Question 2. Convert the following temperature to Kelvin scale. So friends, as I told you, the same thing, same procedure we will repeat over here. The same procedure, that we will add 273 into the 25 degree. So we'll get the 298 Kelvin. Next question. Question 3. Give reason for the following observation. Naphthalene balls disappear with time without leaving any solids. See friends, we know that naphthalene balls undergoes with the sublimation. Sublimation is the process where solids converted directly to the gas forms. So direct formation of the gas here occurs with the naphthalene balls. The change of a state naphthalene balls from the solid to liquid takes place. Solid gas takes place, not a liquid forms. Thus, naphthalene balls disappear with the time without leaving any solids. Second, we can get the smell of a perfume sitting several meters away. See friends, gaseous particles, as we know, the gaseous particles possess high speed and large spaces between them. So large space between them and high speed they have. These particles of the perfume mix with the gaseous particles. Perfume mix with the gaseous particles. So these gaseous particles move the perfume particles to the distance. So we can get the smell, wherever we are sitting, we can get the smell of the perfume. Question 4. Arrange the following substances increasing order to forces of attraction between the particles of the water, sugar and oxygens. See friends, as we know, sugar is solid. So sugar is solid, so the force of attraction, always solid substance have a larger than the any other substances. Water is liquid, so the force of the attraction here are weaker than the sugar. And oxygen is a gas. The force of attraction of is the weakest of the gases. So we can arrange the oxygen, water and sugar as we have to arrange it in the increasing order of the force of attraction. So oxygen compared to the oxygen, water have a higher attraction. Compared to the water, the sugar, the solid substance have the higher attraction of force of attractions. Next question. Question 5. What is the physical state of water at 25 degree, 0 degree and 100 degrees Celsius? See friends, 25 degree is at the liquid state. As we know, it's a room temperature also. But at the 0 degree, water can exist in the both solid and liquid. Why? It may be depend whether the temperature after getting the latent heat, uh, it will have the it will have latent heat, then it will have the liquid form maybe. Or suppose it don't have latent heat, then maybe the solid form also. So if it gets the latent heat, then the ice starts changing into liquid form and it will be a water. So it can be in both the state. Water can exist in both the state, liquid and solid, because that is temperature getting the heat equal to the latent heat of a fusion, the solid forms of a water. That ice starts changing into the liquid forms. That now at 100 degree, what will be the status of the water? Water can exist as both the liquid and gas. At this temperature, after getting the heat equal to the latent heat of vaporization, water starts changing from its liquid state to gaseous state. That is called the water vapor. Question 6. Give two reasons to justify water at a room temperature is a liquid, an iron almira, which kills also as a solid at a room temperature. See, water at a room temperature, that is a 25 degrees centigrade, water is liquid because it has the following characteristics. Which are the characteristics at a room temperature? At room temperature, water has no shape but has a fixed volume. That is, it occupies the shape of the container in which it is kept. At a room temperature, water can flow. But an iron almira is a solid at a room temperature of a 25 degree because it has a definite shape and volume like a solid at a room temperature. It is rigid as solid at a room temperature. So now next question. Question 7. Why is ice at a 273 Kelvin is more effective in a cooling than water at the same temperature? See, ice at a 273 Kelvin has a less energy than the water because both are at the same temperature. Both are at the same temperature, though both are at the same temperature. But what is the reason behind that the ice at a 273 Kelvin has the more energy, less energy than the water, a cooling effect? What is the reason behind it? See, water possesses the additional latent heat of a fusion, but whereas the ice is more effective in a cooling than water because it doesn't have the latent heat of the fusion. Question 8. What produces more severe burns, boiling water or steam? See, steam has a more energy than a boiling water. It possesses the additional latent heat of a vaporization. Therefore, burns produced by steam are more severe than those produced by the boiling water. Next question. See, now this question 9, that's the last question for the exercise. Name A, B, C, D, E, and F in the following diagram showing the change in the state. See here the substances are solid, liquid and gas, and it's all given also we have the increase heat and decrease pressure. Here it is given the decrease heat and increase pressure. What is happening to the substances which is A, B, C, D, E, F, it is given. See, we once give to the A substance A, when you give the increased heat and decreased pressure, then this substance will form the solid forms or will have the fusion or the liquefations. Similarly, when the substance reaches now the liquid forms and the B forms, when again you give the increased heat, there will be the evaporizations or evaporations are going to happen. Again, suppose you are now in the C form, that is the liquid form. Now you are cooling. That means the decreasing the heat and increase the pressures. Is it? So what is going to happen when you increase the pressure and decrease the heat? It is have the condensations start becoming the liquid form. Same with the this liquid form. When you decrease the heat and increase the pressure, it will going to be a solidification, solid substance going to happen. But here it is E is given to you that from the solid it directly to the gas form. Just now we understand When solid substance we convert to the gas form, we know that formation of the substance is in the process called the sublimation. In the naphthalene ball, we understand this is the process of the sublimations. Similarly, now this gas substance become directly to the solid, that is called the formation of the depositions. So this is the only with the chapter 1 class 9. Like, subscribe to my channel for the more videos. Thank you for watching.